Assalamu alaikum. Welcome to lecture 12 of NLP. Today, we will complete our discussion on Word2Vec and dense embeddings, and then we will move on to language modeling. And in particular, we'll start with the N-gram language model, which is a probabilistic language model. So that is basically the agenda for today. So are there any questions before I get started? Okay. All right. So in the last lecture, we talked about Word2Vec, which was a technique for mapping words to vectors that are rich representations for those words. And we discussed the approach using a feed-forward neural network in which we developed a neural network for predicting the context word given the central word. Uh, so this classification model was learned over a large amount of data, but the final classification was not the goal. The parameters of the neural network that were formed or learned during this process were then used as embeddings. Okay, so this was the idea of Word2Vec. Very briefly, so we mentioned how to create the training data for Word2Vec from corpora, which is simply text written in a particular language. And we also discussed how to find positive and negative examples from that data. No external supervision is required, no human annotation is required. So in other words, this is also sometimes called self-supervision. So no external annotation is required. So we can create the data, and then using that data, you can train a two-layer feed-forward neural network. After training the neural network, you get two weight matrices for the first layer and for the second layer. So you can call them W1 and W2. 1 and 2 you can think of as the index for the layer. It could be written in the superscript, but I've just written it in front of it. So of course, these two matrices have different dimensions or shapes based on how we have run the neural network. But from those dimensions, you can extract the embeddings. So if I talk about W1 and the method that we talked about earlier, the dimension for this was typically the hidden layer, with let's say is N1 by the input layer N0. ठीक है? The hidden layer usually is smaller. So let's say हमने 300 space की embeddings निकालनी है. 300 by input space is usually the vocabulary size. So this could be large, 20,000. So 300 rows and 20,000 columns. So each row is now an embedding for the corresponding word in the vocabulary. So the first row of this matrix is the embedding for the first word in the vocabulary. The second is the embedding for the second word, and so on. And this is 300 in length, and it is usually dense. In other words, there will be very few zeros there because this is learned through a neural network, uh, which has compressed the input space from 20,000 to 300 using the continuous sigmoid activation function. Sigmoid-like activation function. It could be a tangent hyperbolic or a rectified linear unit. ठीक है? All right. Of course, you can get an embeddings from W2 as well. If you want to use both of them, then you can take the average of the two and use it in your analysis. Uh, so these are called static embeddings because you learn them once on large amounts of data and then save them for reuse. Learned and saved for later use. Usually we save them in a vector database, and as such you can retrieve them based on similarity. So given a query vector, you can find all the other vectors that are close to it. Okay? And many of these embeddings are already developed and they are available mostly freely on the web, and you can download them and use them in your applications. Okay? And they are available for almost all languages. So last time मैंने पूछा था पश्तो में अवेलेबल है कि नहीं है. Did anyone look it up? कोई यस या नो में बता सकता है या कोई रेफरेंस दे सकता है कहाँ से मिल सकती है? So actually, a simple Google search would tell you that there are embeddings available for the Pashto language. They are also available for many other languages like Urdu and other variations. And they have been trained on different corpora. So, and if they are trained on different corpora, so they can use in the appropriate domains as well. So medical corpora पे train किया गया तो medical applications के लिए वो appropriate होगा, and so on. ठीक है. So now just a quick discussion on how we can use these embeddings in a feed-forward neural network. So let's say we want to develop a feed-forward neural network for document classification. ठीक है? So input would be the document representation. So input is the doc representation. So how would you represent an entire document? And a document usually consists of multiple words. ठीक है? And also that's one issue. That's one thing. And secondly, the length of the document in terms of words is also different for different documents. Remember when we previously represented documents using TF-IDF? So this vector, all documents were represented in same length vectors, right? And the length of the vector was equal to the vocabulary size. So even if the document was 10,000 words long, हमारा उसका vector 20,000 ही होगा, where 20,000 the vocabulary size. और लेट्स से वो डॉक्यूमेंट छोटा है, लेट्स से सिर्फ 200 वर्ड्स हैं, फिर भी उसकी रिप्रेजेंटेशन 20,000 साइज वेक्टर में ही होगी. दिस इज हाउ वी कंप्यूटेड TF-IDF, right? So of course, for this case, you will develop a neural network with 20,000 inputs, and it will be applicable to all document sizes. Even if the document is small or large, uska vector representation is still 20,000. So it will work fine. And of course, the output layer आपकी जो भी classification problem उस हिसाब से होगी. If it is a 3 class problem, तो 3 nodes होंगे. 10 class problem, तो 10 nodes होंगे, and so on. ठीक है? But let's say if you want to use embeddings as representation for documents, तो फिर हम क्या करेंगे? So use embeddings for representing docs. ठीक है? एक तो issue आएगा कि since documents, so let's say let me just take an example. Let's say 100 length embeddings per word. ठीक है? So if our document is, let's say 100, let's say 200 words long, so 200 words long doc would imply that input vector would be of size how much? 200 into 100, ठीक है, which is 20,000. But let's say आपका, so if you have an input document of 10 word doc, then of course you'll have 100 into 10, just 1,000. But neural networks में तो आपके पास fixed number of inputs होते हैं. So how can you handle this? Or how should we handle this? Any ideas? Uh, there are actually two, three simple ways of doing this. One is taking a single vector of size 100 for the complete document. ठीक है, अब इसमें ऑप्शंस दो तीन हैं. टेक द एवरेज ऑफ ऑल वर्ड्स, ठीक है. द अदर ऑप्शन इज यू कैन टेक ए मैक्स फॉर ऑल वर्ड्स. So kind of average pooling and max pooling. Okay. So you will be left with a size of 100 for each document. But the issue, okay, this would work well in some cases, but usually the issue is that if you average the embeddings of words in a document, first of all, you lose, of course, the sequence information because you don't know which word comes before the next word. And secondly, the various representations of all those words would be averaged up. So that might be appropriate for your classification problem or any other problem, or it may not be. So you will have to try it out and find out whether it works or not. So average का भी यही scenario होगा, max का भी वही scenario होगा. So average pooling या max pooling से आप any length document को एक fixed length vector से represent कर सकते हैं, where each word is represented as an embedding. ठीक है? And then of course once you have done this, you can use a neural network, a feed forward neural network. ठीक है? So this is one approach. The other approach is of course truncation slash padding. ठीक है? So let's say आप assume कर सकते हैं कि I will only take the first part, first 50 words of the document or some selected 50 words of the document and use that as input to the neural network. ठीक है? So if the document size is less than 50, I will pad the remaining vectors. Usually padding में आप कोई fixed value ले लेते हैं vectors की, let's say -1, -1, -1 या 0, 0, 0. ठीक है, एक कोई fix ले लेते हैं आप. ठीक है. So that is so basically if the document is long, you truncate it to 50 words. If the document is small, then you pad the remaining so that you still get a fixed length input to the feed forward neural network. ठीक है? So again here there is loss of information. So if you have just taken the first 50 words, for example, then you have lost the information for the remaining words in the document. If you have taken some selected 50 words, then of course this will depend on your domain knowledge, which 50 words to select from a given document to use as input or representation for that document. Okay? And of course, if a document is smaller than 50, then आपके बाकी सारे inputs padded होंगे. ठीक है? So is this point clear? So of course, later on we will see models that take input in the form of recurrent information, so recurrent neural networks as well as transformer. तो उसमें ये वाला हम प्रॉब्लम टू ए लार्ज एक्सटेंट अवॉइड कर सकते हैं. रिकरेंट न्यूरल नेटवर्क्स में तो कम्प्लीटली अवॉइड कर सकते हैं, ट्रांसफार्मर में टू सम एक्सटेंड अवॉइड कर सकते हैं. उसमें भी आपको ट्रांकेशन या पैडिंग करनी पड़ जाती है ट्रांसफार्मर में, एज वी विल सी लेटर ऑन. ठीक है. ओके, सो example for let's say we have a document, very small document. I am छोटा ही ले लेते हैं because I want to complete this quickly. So for example, I study, a very small document, 2 words. अब I की कोई embedding होगी, and let's say again embedding मैं छोटी ले लेता हूँ. Let's say 0.5, 0, 0.1, -0.1 and 0.5. ये I की embedding है और study की embedding. ठीक है. Again, remember embedding अब for example sake I'm taking embedding of size 4. तो स्टडी की embedding ले लेते हैं 0.3, 0.2, -0.2 एंड 0.3. ठीक है. एवरेज पुलिंग क्या होगी? यू सिंपली, लेट्स से दिस इज माय कंप्लीट डॉक्यूमेंट. डॉक्यूमेंट सिर्फ 2 वर्ड्स हैं. ज्यादा वर्ड्स हो तो वो सारे लिखे जाएंगे उनकी embeddings एंड देन डू दिस प्रोसेस फॉर ऑल ऑफ देम. So average pooling would give you the vector where you take the average for each element of the 2 vectors. ठीक है. तो ये पहला वाला 0.5 और 0.3 का एवरेज होगा, जो 0.4. ठीक है. दूसरा 0.1 एंड 0.2 है, 0.3 का 0.15. तो तीसरा है -0.1 एंड -0.2, दैट विल -0.15. ठीक है. एंड आखिरी वाला 0.4. I hope I have done this right. So we are simply taking the average. ठीक है. तो मैक्स पूलिंग क्या होगी? We take the max of the 2 vectors. In this case 2, but if they are more than 2, then जो भी max है. ठीक है. तो max मेरे पास 0.5 आ जाएगा, इधर 0.2 आ जाएगा एंड -0.1 आ जाएगा एंड देन 0.5. ठीक है. So this would be the vector for max pooling. And then we will use this vector as a representation for the document. So the document vector size is also of the same length as the embedding size. So these are very simple ways of ensuring that we can use a feed-forward neural network given documents are represented by embeddings. There are more sophisticated ways as well, जो जिनकी आपको APIs मिल जाएंगी. But later on, we'll also talk about contextual embeddings. So embeddings that change with the context. ठीक है. एक वो ऑप्शन हो सकती है और दूसरी, एज आई सेड, आपको additional tools मिल जाते हैं that work somewhat similar to contextual embedding and Word2Vec to give you vectors that are more richer, much richer for larger chunks of document, larger chunks of linguistic units. So for example, doc2vec एक technique है, so that would convert a document to vectors based on embeddings. And then, of course, there are other techniques out there. So once you use this approach, you will feed your document all its words into the document and give you a vector through a neural network. So कुछ ये वाली थोड़ी सी techniques would become much more clearer when we discuss contextual embeddings in the case of transformers. ठीक है. So in other words, so just to summarize, actually फिर 2-3 options हैं आपके पास. एक option तो ये है कि आप एवरेज या मैक्स पुलिंग कर लें, दूसरी ऑप्शन ये है कि ट्रंकेट स्लैश पैडिंग कर लें, और चौथी ऑप्शन ये है कि यूज कंटेक्चुअल एम्बेडिंग। सो तीसरी ऑप्शन कंटेक्चुअल एम्बेडिंग, और चौथी ऑप्शन यूज सम dedicated tool that gives you representations for documents directly from embeddings uh, of words within that document. ठीक है? So multiple options are available. Okay. So now just a few more things before we wrap this up. First of all, हम आपको याद होगा हमने context window की बात की थी, जिसको हमने denote किया था by the letter C. So this is the number of words before and after a given word that defines the context. ठीक है? So C1 होगा तो इसका मतलब है one word before and one word after. So context window आप समझ लें 3 की है. एक central word है, एक one word before, one word after. ठीक है? Let's say C2 है तो 2 words before, 2 words after. So total context window size 5 हो जाएगी. So now the question is कि what does this have? What is the impact of this C on the types of embedding that we get? So people have studied this extensively. So when C is small, so C, let's say छोटा है, let's say 1, 2, maximum 3, let's say, then the embeddings capture syntactic relations uh, to a greater extent. In a way, there is no hard and fast thing, but if you keep C small, then the embeddings would highlight syntactic information more than semantic information. So why is this? So let's say C1 hai, so then embeddings would capture how words are used in correctly written sentences of a particular language. In other words, it will capture the grammar of that language. Syntax and grammar, as we mentioned earlier, are kind of used interchangeably. ठीक है? So for example, a determiner the है, for example. So the के बाद most likely एक noun आएगा. So the car, for example. So the and car, these are uh, two words that are close together, meaning that C यहाँ, for example, one है. So if you keep C1 in your training, so your embeddings that you get would emphasize syntactic relationships. ठीक है? उसमें POS tags की information ज़्यादा highlight होगी, grammatical usage ज़्यादा highlight होगी, co-occurrence of words ज़्यादा highlight होगी. For example, there might be some compound words. वो हाईलाइट हो जाएगा. ऑल्सो प्रॉपर नेम्स फॉर एग्जाम्पल वो हाईलाइट हो जाएंगे. ठीक है? So proper names, for example, are written together. Asim Kareem, Kareem occurs with Asim. For example, proper names of companies, for example, Lahore University of Management Sciences. Close to Lahore, you see the word university, for example. So that is what is observed if you keep C small. So if you keep C large, so let's say C is, let's say, greater than, let's say, 5, if C is large. So then embeddings capture semantics to a greater extent. And semantics, as you remember, are many things, as we saw before. Semantics could be a semantic field, semantic could be connotations, semantics could be antonymy, semantics could be polysemy, and so on. ठीक है? So semantics would be more highlighted in the embeddings if you learn them using when C is large or larger than 4, 5. If you use keep C small, 1, 2, 3, then the embeddings that you get would kind of highlight grammatical information or grammatical usage of words. Okay? And the embeddings that are available on the web, people have developed them for various values of these already available. Hai. Different C's के लिए available हैं, different lengths के लिए available हैं, different corpora के लिए available हैं. So it's a very useful resource. आपको खुद ही कुछ नहीं करना पड़ता, सिंपली पिक दोज एम्बेडिंग्स अप दैट आर अप्रोप्रिएट फॉर योर एप्लीकेशन एंड यूज देम. ठीक है. एनी क्वेश्चंस ऑन दिस? So moving on, some so using embeddings, you can learn a lot about the language and the people who wrote that language, or the you can say the time period from which that language were written, or from the geographical or cultural space from which that language was written. Remember, these embeddings capture meaning as of words as they're used in text. Okay? So in this way, you can find out many things. So for example, historical historical usage. Okay? So so usage of words have evolved over time. So for example, in the 1800s, Old English was quite commonly used. So for example, giveth would might be a word that is used, but maybe giveth may not be seen in recent writings at all. ठीक है. सो शेक्सपियर्स की राइटिंग में इस तरह के स्पेलिंग्स या इस तरह के वर्ड्स होंगे, बट रिसेंटली इस तरह के वर्ड्स आपको नहीं मिलेंगे. ठीक है. ऑल्सो the context in which a particular word is used may change or evolve over time. So there are some examples given in the slide. I wouldn't go over them. You can read them on your own time. So for example, a word like awful was used with different meanings 200 years back as compared to, for example, today. ठीक है. उस वक्त इसको लोग डिफरेंट तरीके से इंटरप्रेट करते थे, अब लोग इसको डिफरेंट तरीके से इंटरप्रेट कर रहे हैं. एंड सिमिलरली यू विल फाइंड अदर words as well that have been used differently over time. So by the way, you can study these historical evolution of words on various websites. You just need to, I think, do a Google search. आपको मिल जाएंगी various sites that have studied the evolution of usage of words over time. ठीक है. So maybe I don't need to mention specific. Google Ngram Viewer was one of the older ones. वो अभी भी available है, वो आप use कर सकते हैं, but और भी available है. So Google Ngram. Ngram हमने अभी start करना है, but the same idea applies here. So you can use this, and there are others as well, and others. So historical usage आप study कर सकते हैं, and then also cultural usage slash biases. ठीक है. And this can also change with time. Historically, आपकी usage and biases can change. So, for example, if you have, and for example, so gender bias, for example, would be quite prevalent in writings even till today. Even if you take writings from, let's say, 1980 onwards, उसमें भी cultural bias नजर आएगा. So you will find that the word father, for example, is closely related to words like, for example, doctor, scientist, but it will not be closely related to words like homemaker, for example, nurse, and so on. ठीक है. So this is just reflecting how culture has adopted these occupations. So usually doctors are mostly male, and nurses are usually mostly female. So this bias would come into your embeddings as well. So embeddings for female and nurse would be closer as compared to male and nurse. तो जब मैं कहता हूँ क्लोजर है एम्बेडिंग स्पेस में, एंड यूजली हम क्वांटिफाई करते हैं कोसाइन रिलेटेडनेस से, जो हमने लास्ट टाइम डिस्कस किया था. ठीक है. सो जेंडर बायसेस हो सकते हैं, एथनिक बायसेस हो सकते हैं, रिलीजियस बायसेस हो सकते हैं. यू कैन फाइंड मैनी ऑफ दीज बायसेस इन written text, and this would then be carried over to your embeddings. And if you use those embeddings in applications that are sensitive to these embeddings, these biases, then they will also propagate to those applications. So you need to be careful. So let's say if आपने एक application बनाई है based on these embeddings for, let's say, job classification. So that embedding, that application may give unfavorable uh, rating to a female who is a doctor, for example, as opposed to a male who is a doctor. ठीक है? So this is a possibility that you need to be aware of in your applications. So there are techniques available for debiasing embeddings. So we won't go into the any in details of any of these techniques, but just to mention, there are techniques out there that you can use to debias or somewhat remove the bias in the embeddings. ठीक है? Uh, Finally, when Word2Vec and such methods were proposed earlier on, people found very interesting analogies that were satisfied by vector arithmetics. ठीक है? So in other words, they were excited that they can use vector arithmetics, vectors of words, and their arithmetics to kind of derive other words. So for example, so one example that was kind of quoted in uh, literature is, so for example, male is related to king just as female is related to queen. ठीक है? So let's say if you have vectors for all of these, and let's say maybe one of these is not available. So what you can do is you can do simple vector arithmetic. ठीक है? So for example, male plus king so should be equal to female plus queen. ठीक है? So you can then apply simple arithmetic here. ठीक है? So female is over there. So male plus king minus female would give you a queen. ठीक है? So let's say queen का vector आपके पास नहीं था, तो you can approximate the vector for queen using this simple vector arithmetic. ठीक है? So king में से आप female मेल प्लस किंग करके उसमें फीमेल माइनस करें, तो यू विल गेट ए वेक्टर दैट्स वेरी क्लोज टू क्वीन. ठीक है? तो इस तरह लोगों ने और भी डिफरेंट नॉलेजेस निकाली हुई हैं. तो फॉर एग्जांपल सिटीज एंड कंट्रीज एंड कैपिटल्स, फॉर एग्जांपल सो फ्रांस एज पेरिस, एंड फॉर एग्जांपल पाकिस्तान एंड इस्लामाबाद, एंड देन ऑफ कोर्स अदर्स एज वेल, फॉर एग्जांपल डॉक्टर एंड हॉस्पिटल, and then mechanic, for example, workshop. ठीक है? And so on. So these analogies can be used to approximate any vector that is not known. So this actually generated quite a lot of interest in early years, but later on it kind of interest faded because it didn't work all the time. And they found out that it typically worked for frequently occurring analogies. ठीक है? And of course, the final result that you get using these analyses may not be all that accurate as well. They will be approximate, but not that accurate. But anyway, you can still try this out and you will find interesting results. ठीक है? Uh, so so we so far talked about only Word2Vec, ठीक है? But इसके अलावा भी और techniques भी हैं, ठीक है? So we won't go into the detail, just to give you the name. एक initially glove या GloVe for global vectors was also quite popular, but अब वो कम popular हो गई है. GloVe was actually based on co-occurrences and a prediction model based on co-occurrences. While if you recall, Word2Vec is based on a prediction model based directly on input outputs, not the co-occurrences. So GloV is based on co-occurrences. Co-occurrences हमने पहले पढ़ा था, word context matrix. जो word context matrix बनता है उसमें co-occurrence values होती हैं, ठीक है? So GloV is based on co-occurrences, while Word2Vec is based on, you can say, predictions of output given an input. And then there are others as well, which are variations of Word2Vec. So, but they are kind of less common nowadays. Word2Vec की mostly use होता है. ठीक है? Okay. So any questions? Okay. So that kind of concludes our discussion on sparse embeddings as well as dense embeddings, and also a discussion on some of the characteristics of these embeddings and maybe some harms that can be associated with the uh, naive use of these embeddings. So harm like for cultural biases or discrimination can also arise by using these embeddings without having proper knowledge of what biases they contain. ठीक है? So now let's move on to language modeling. This is an entirely different topic. ठीक है? So far, we have focused on representing documents as vectors as well as words as vectors. But especially when we are representing documents as vectors, we disregarded the fact that words appear in a document in a particular sequence. So we said that words were a set of words. So the sequence was not important. So we used the actual terminology called bag of words. Okay? So sequence info was lost in representations. Okay? So, but language, as you know, is a sequence of words and sequence of other linguistic units like tokens or subwords. And the sequence does contain information. So language modeling is basically thus the study of language as it is used in sequence. Okay? And we will start with probabilistic language modeling. Probabilistic language modeling, which is also sometimes called in NLP n-gram language modeling. ठीक है? So what is the idea here? So language, as I said, is a sequence of words. So let's say if I want to find the probability of a particular sequence of words, as maybe it appears in a sentence, I live in Lahore. So now this is the probability, a joint probability of these four words that appear in this particular sequence. I first, then live, and then in and Lahore. ठीक है? And let's say I have another sentence, live I Lahore in. ठीक है. So based on your our intuition, किसकी probability ज़्यादा होगी? Both of them are sequences. पहले वाले की probability ज़्यादा होगी या दूसरे की ज़्यादा होगी? Which is more likely to, sequence one में ज़्यादा होगी because the first one, why? Because that is the correct way of writing English. The second one has mixed up the order in which those words are written, and this is not used in correct writings. So grammatically it's incorrect. ठीक है? Since it will not appear in your writings, its probability would be very low. Similarly, so let's say मेरे पास कोई इस तरह का क्वेश्चन है, uh, uh, okay, cheese given I like burger with. ठीक है? So this is a conditional probability of cheese given the context I like burger with. So what should come after with? So one probability is cheese. Another option, let's say, is car. Let's say I like burger with. So again, now which probability would be higher given correctly written language? So the first probability would be higher because cheese one would be higher, right? So because it follows the rules of the language and this would be used quite frequently, or it naturally would be used quite frequently in written text, while the second one is unlikely, burger with car, that is unlikely to be seen in text. Okay? So these, so of course you can build various applications if you are able to quantify these probabilities. So spell checking आप कर सकते हैं. Let's say आप टाइप कर रहे हैं अगला वर्ड क्या होगा, स्पेल चेकर आपको बता देगा बेस्ड ऑन द कंडीशनल प्रोबेबिलिटी ऑफ व्हाट यू हैव रिटन कि नेक्स्ट वर्ड की प्रोबेबिलिटी कौन सी होनी चाहिए. तो स्पेल चेकिंग कैन बी ए वेरी easy or direct application of language modeling, predicting the next word. ठीक है. ऑल्सो लेट्स से जब आप गूगल बॉक्स में कुछ वर्ड लिखते हैं, पहला वर्ड लिखा वो अगला वर्ड खुद ही आपको बता देता है. अगेन दिस इज बेस्ड ऑन हाउ पीपल हैव रिटन क्वेरीज इन पर्टिकुलर सीक्वेंसेस. ठीक है. दिस इज ऑल्सो बेस्ड ऑन लैंग्वेज मॉडलिंग. ठीक है. And then, of course, as we'll see later on, language modeling is actually the foundation of almost every application in NLP. Okay? Because from if you're able to predict the next word given some context, so you are kind of understanding that language and you can use that to generate language, for example. So text generation का basis ही language modeling है. ठीक है? As we'll see again later on in this course. एंड सो ऑन. सो टेक्स्ट जनरेशन की एप्लीकेशन हर जगह है. समराइजेशन करनी है टेक्स्ट जनरेशन है, ट्रांसलेशन करनी है टेक्स्ट जनरेशन है, सिंप्लीफिकेशन करनी है टेक्स्ट जनरेशन है. बाय द वे आजकल जो है ना, जनरेशन से प्रॉब्लम्स हम ज़्यादा सॉल्व कर रहे हैं बिकॉज हमारे पास लार्ज लैंग्वेज मॉडल ऑलरेडी अवेलेबल है. डायरेक्ट क्लासिफिकेशन भी हमने करनी है तो हम जनरेशन से कर रहे होते हैं. ठीक है. एंड अगेन वाई? बिकॉज वी हैव ए लैंग्वेज मॉडल बिहाइंड इट. ऑफ कोर्स क्लासिफिकेशन के लिए आप डायरेक्ट लर्निंग भी कर सकते हैं जैसे हमने पीछे देखा. But since LLMs, large language models are widely available, लोग classification भी text generation से कर रहे हैं. Okay, so now let's study this more formally. So let's say what we are interested in, we want the probability of some sequence of words W. ठीक है, एंड प्रोबेबिलिटी ऑफ W1, W2, W3 डॉट 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 टू W, लेट्स से n कर लेता हूं मैं नोटेशन, ठीक है. So this is so if I apply, so first of all, let's say if you want to estimate this probability, would that be easy? Estimation हम typically किस तरह करते हैं? We look at large amounts of text that is written and see whether this particular sequence occurs. And if it occurs multiple times, we take the basically the average of it. The count divided by G, capital W is the sequence, is a sequence. And W1, W2, W3, W4 is the individual words in the sequence in order. The one जो मैंने लिखा है, it means that it's the first word in sequence. It doesn't mean that it is a particular word from the vocabulary. It's a word from a sequence. Okay, so W1 or in general WI is the ith word in the sequence, and WI would be any word from the vocabulary. Okay, can be any word from the vocabulary. So actually हमने ये actually लिख लिया है, तो खैर okay, we can come back to that later on. So I was saying कि estimating probabilities of long sequences is quite problematic. You won't be able to find that exact sequence many times, and if you find it even once, the estimate might be very poor. So we often use approximations to improve this. So if we let me take a smaller sequence, W1, W2, W3 and W4. So इसको आप using probability theory, you can rewrite this using product rule as last word जो था मेरे पास W4 था, ठीक है, given W1, W2, W3, probability of W1, W2, W3, ठीक है, इस तरह लिख सकते हैं ना. सिंपली प्रोडक्ट रूल लगाए, एक को मैंने कंडीशन कर दिया on the by taking the last word condition on the previous words and then of course multiplied by the probability of the previous, the context, ठीक है. And actually you can repeat this process. So I can repeat this process. So probability of, so W4 था, so W1, W2, W3, then I have W3, W1, W2, then I have W3 था, W2, W1 and W1. Is this, we can do this right? ठीक है, so simply applying the product rule of probability theory. अब इसमें भी आप देखें, तो इफ यू वांट टू एस्टिमेट दिस प्रोबेबिलिटी, इसमें भी आपको चारों चीजें चाहिए, पूरा ये सीक्वेंस चाहिए, फिर ये आप प्रोबेबिलिटी एस्टिमेट कर सकते हैं, ठीक है. So you still need the complete sequence to appear in text in your training text, and it should appear multiple times at least to get reasonable estimates. ठीक है. So then by the way, अभी जो इस ये इक्वेशन जो मैंने लिखी, there is no approximation. So this is exactly equal to the joint probability of W1 to W4. ठीक है, कोई approximation नहीं है. So now we'll apply some approximations, basically the Markovian, or you can say the n-gram approximation, or context approximation. So we can say that the probability of a word depends on only the previous one, two, three, or four words, whatever that we want to define. Okay? So let's say if you say that the probability of word depends only on the preceding word. Okay? So that in that case, so context size is equal to 1, then our equation would become probability of W4 become W3, probability of W3, W2, probability of W2, W1, and of course probability of W1. Okay? So context is just the preceding word. So now my full sequence has been simplified to this in this form, where I need the conditional probability of a word given its preceding word. So this model in which we take the preceding word only as context is called the bigram model. Bigram meaning that it takes two words at most in running text. Okay? So this is a bigram model. And of course, this is also using the Markovian assumption. Markovian assumption यही होती है कि we just consider in a sequence of words, in this case, or sequence of random variables, the current random variable depends only on the observation of the previous random variable. So given the previous value. ठीक है? ठीक है? So this is bigram. Of course, we have simplified and we have reduced the context to just the previous word. And you might be able, you will be dropping longer context. So of course, longer context can be taken. So इसी तरह आपके पास trigram models भी हो सकते हैं. ठीक है? So trigram model इसी केस में क्या होगा? Probability of W4 given W. Uh, let me first write this. W4 के बाद आता है W3 and 2 and W3, and then we have W3, इसके प्रीवियस दो क्या होंगे हमारे पास W3 के W1 and W2, and W2 का ऑफ कोर्स एक ही प्रीवियस है W1 and then W1. ठीक है? So this would be a trigram model where the maximum length of word in a probability is 3. Context 2 है और maximum is 3. So Markovian basically assumption is basically saying that we only consider a context of one, the preceding word only. That is called Markovian in probability theory. So Markov chain, by the way, this is actually a Markov chain. So there is actually some overlap of what I'm discussing here and what I'm going to discuss in applied probability. So by the way, applied probability की भी videos मैं upload कर देता हूँ, तो I think you should study or go over that video as well. मैंने एक लेक्चर कल किया था, एक मेरा कल थर्सडे को भी लेक्चर है, और फॉलोइंग ट्यूसडे को जो लेक्चर है उसमें हम HMMs पढ़ेंगे, हिडन मार्कअप मॉडल्स इन इन द कॉन्टेक्स्ट ऑफ NLP, और वो हम इस कोर्स में अभी स्किप कर रहे हैं. वी विल नॉट कवर इन दिस कोर्स बिकॉज अब बेसिकली पीओएस टैगिंग या नेम्ड एंटिटी रिकग्निशन हम HMM से नहीं करते इन प्रैक्टिस. वी टिपिकली यूज RNNs एंड ट्रांसफॉर्मर्स. सो बट आई विल कवर दैट इन द अदर कोर्स. तो उसकी भी वीडियो अवेलेबल है. आई वुड सजेस्ट कि वो आप भी देखें. Yeah, I think for extra reading, you should go over that lecture as well, but it's not mandatory. तो उसमें थोड़ा सा एक डिफरेंट पर्सपेक्टिव थोड़ा सा आपको नजर आएगा, और विथ दैट पर्सपेक्टिव इज एक्चुअली यूजफुल इन अंडरस्टैंडिंग। तो फॉर एग्जांपल जो कल का लेक्चर मेरा था डॉक्यूमेंट मॉडल्स का, तो वो इट वाज ए पर्सपेक्टिव प्योरली बेस्ड ऑन प्रोबेबिलिटी थ्योरी। ठीक है। और जो हमने फॉर एग्जांपल टीएफ आईडीएफ पढ़े या रॉ काउंट्स बेस्ड डॉक्यूमेंट रिप्रेजेंटेशंस पढ़े, तो वो हमने प्रोबेबिलिटी थ्योरी को लेके नहीं आया उसके अंदर। सो आई थिंक इफ यू गो ओवर देम यू विल गेट ए बेटर अंडरस्टैंडिंग, आपकी अंडरस्टैंडिंग सॉलिडिफाई होगी। एंड सेम फॉर probably the lecture tomorrow as well as on Tuesday the following week. ये थे वीडियोस बाय द वे, मैं वो केड लैब लम्स की चैनल पे ही अपलोड कर रहा हूँ, तो आपको मिल जाएंगे वहाँ। ठीक है। So, okay, so you have the trigram model, and similarly, you can have higher order n-gram models in general. ठीक है। So, we have actually now simplified, okay, of course, there's one final case, the unigram model. The unigram model में हमारे पास क्या हो जाएगा? No context. The probability of W4, probability of W3, probability of W2, probability of W1. ठीक है। So in other words, each word is considered independent of the other. ठीक है। But इसमें एक कैवियट है, स्पेशली फॉर इफ यू वांट टू रिलेटेड डायरेक्टली टू प्रोबेबिलिटी थ्योरी। इसमें जो W1 W2 W3 ये सीक्वेंस इंडेक्स है, so you cannot change the order. By the way, if you are able to change the order, तो ये by the way मल्टीनोमियल डिस्ट्रीब्यूशन बन जाएगी। बट यहाँ ऑर्डर हम चेंज नहीं कर रहे, एक स्पेसिफिक ऑर्डर है, तो ये मल्टीनोमियल डिस्ट्रीब्यूशन नहीं है। ठीक है। सो इट इज ए सीक्वेंस बट इट्स ए यूनिग्राम मॉडल। ठीक है। So now let's move on to estimation. How do you estimate these probabilities? So we will take the example of bigrams. So we want to estimate probabilities from, of course, corpora or text that is available to us. So let's take the example of bigram models. ठीक है। So bigram models में typically क्या होगा? Probability of W2 given W1, इसकी probability निकालनी है हमने। ठीक है। और इसका estimate निकालना बाय द वे। तो probability, true probability obviously हमको पास available नहीं है। The probability that we get is an estimate from data. So usually if you want to be pure in notation, तो ये p जो है इसको आप p prime कह लें, p hat कह लें, it's not the true probability, it's estimated probability. ठीक है। So how do you estimate this? So basically simply the count of the occurrence of W1 and W2. So this is of course the co-occurrence count, raw count, as we saw in co-occurrence matrices, divided by the uh, count of the context, which is W1. Okay. So we estimate this in this way. And if you want to build a language model, which is a bigram language model, you will have to compute this for all words and all pairs in your vocabulary. ठीक है। All sequence, नहीं। So this is actually probability estimation. ये यहाँ log नहीं यूज हो रहा, ये डायरेक्ट MLE एस्टिमेट है, maximum likelihood estimate है, in which we are counting the number of times that the two words occur together in sequence, dividing by the total number of times that we have seen the context. ठीक है? The context, of course, wi would also occur in sequence. This wi may occur with other words as well, but we will count all of them because that's the context. ठीक है? So for example, let's say मैं निकालना चाहता हूँ probability of live I live. In other words, जो मेरे पास सीक्वेंस है वो I और live है. ठीक है? So इसमें अब आपने I और live का काउंट देखना है. See count of I and live divided by the count of I. ठीक है? So let's say for example I and live आपके कॉर्पस में 10 दफ़ा आ रहा है और आपके पास I let's say 100 दफ़ा आ रहा है, तो ये आपके पास प्रोबेबिलिटी इसकी आ जाएगी. सो बाय द वे जो I 100 दफ़ा आ रहा है उसमें I live जो है वो 10 दफ़ा आ रहा है एंड I other words would occur 90 times. ठीक है ना? इसी तरह हमारे पास 100 हुआ. कॉन्टेक्स्ट हमारे पास, हाँ ठीक है. सो आई सॉरी कॉन्टेक्स्ट हमारे पास था लिव आई है ना, आई कॉन्टेक्स्ट. ठीक है. लिव, तो यहाँ पहले अदर वर्ड होगा एंड जस्ट अ सेकंड. अदर वर्ड एंड आई, एक सेकंड. लिव. ठीक है. सो इसमें अदर वर्ड में कुछ भी हो सकता है. दिस वुड बी 90. अदर वर्ड में शी लिव्स हो सकता है, ही लिव्स हो सकता है, दे लिव हो सकता है एंड सो ऑन. ठीक है. So this is W2. There's a W2 there as well. The sequence वही है. W हमने कहीं यूज नहीं किया. So this was the typo here. ठीक है. So given a large corpus, you can thus estimate the probability, all these conditional probabilities. These, if you think in terms of a Markov chain, these are transition probabilities. What is the probability that you transition from I to live? So this is also called a transition probability in the context of a Markov chain. What is the probability that I will transition from I to live? Or in other words, what is the probability that live would come after the word I? ठीक है? Where this I, live and all other words in the vocabulary are the states of the Markov chain. ठीक है? अ, ठीक है. अच्छा, एक्चुअली हमको ऊपर से डीन एंड अदर्स पीपल हैव मेंशन दैट वी शुड मेंशन इन क्लास और गिव टाइम भी दें कि आप लोगों ने वो आपको एक एवेल्युएशन आया होगा सर्वे, वो आपने भरना है हर कोर्स का. तो इस कोर्स का आई वुड सजेस्ट के फॉर एटलीस्ट फॉर दोज हु आर हेयर इन क्लास तो वो अभी स्टार्ट कर दें. आपको लिंक आया होगा ईमेल में. ठीक है. सो यू कैन स्टार्ट filling out that evaluation and it would be a feedback for us in terms of how this course is progressing and if we need to make any tweaks uh, down the road. ठीक है? So in other words, so I'm kind of giving you off the last 10 minutes. तो आप इसको फिर भर लें. Of course, the time for this is till I think Sunday. आपको email में आया होगा. So for those who are not here, they can fill it up at their own time. But try to provide as you can say uh, as candid information as possible. Of course, it should be constructive rather than being uh, you can say destructive. तो जो भी कंस्ट्रक्टिव आपके पास कमेंट्स हैं वो आप डेफिनेटली कम्युनिकेट करें. यस. सो द फीडबैक इज अनोनिमस. या एज फार एज आई नो, मैंने वैसे खोल के वो देखा नहीं, बट मेरे ख्याल से हमेशा फीडबैक अनोनिमस ही होता. हैज एनीवन डन दिस फॉर एनी अदर कोर्स सो फार? बिकॉज दिस इज अ न्यू सिस्टम दैट हैज बीन लॉन्च दिस सेमेस्टर. पहले नहीं था ये, तो मुझे भी पूरी डिटेल मुझे भी नहीं पता. But we have been informed that we should do it in class or at least start it in class. जी ठीक है. So anonymous ही होना चाहिए most likely. So you can go ahead and fill out for those who are uh, here, and बाकियों के लिए we'll just send an email reminder. ठीक है. तो फिर if there is anything else that I can contribute here, otherwise I will end the session. So anything else? So as we discussed, I think in the previous lecture, आपका जो next quiz है 20th को है, and of course the mid is on 27th.